Good morning, students. Today we will discuss about the chapter 8 of physics, that is motion. In this chapter we will discuss about rest and motion. You have observed so many things in your daily life. Some of the objects are at rest and some of the objects are in motion. So what is the difference between rest and motion? An object is said to be at rest when it does not changes its position with respect to time or with respect to its surrounding. Whenever an object is at rest, its surrounding will not change. It will remain same whatever be the time. But in case of motion, the object changes its position with respect to time and surrounding. Its surrounding will change with the time. In daily life you observe that birds fly, fish swims, blood flow through the veins and arteries, and car moves. These all are in motion. Atoms, molecules, planet, star and galaxy all are in motion. Their positions changes with the time. That's why they are in motion. Now this rest and motion are relative terms. Why they are called relative? It means an object at the same time can be at rest and can be in motion. It depends upon the observation point. Suppose that you are in a train. The passenger nearby you is at respect. For you, that passenger is at rest. But if a person is outside the train, then the same passenger will be in motion for him. Now, the observation point has changed. So it depends upon the observation point, your reference point, from where you are observing the things. The same object can be at rest and same object can be in motion. Now suppose that you are in a train and you are looking towards a tree on the ground, then that tree will be in motion. But when you come outside the train, the same tree will be at rest when you observe it from the ground. So the same object can be at rest, can be in motion. So rest and motion are relative terms. Now most of the motions are complex. Some objects move in a straight line, some objects move in a circular path, and sometimes there is a combined motion. An object can be in a straight line motion as well as in rotational motion. For example, when you throw a ball also spin about its axis and also move forward. So both type of motions are there in a ball. It is a combination of straight line and rotational motion. Now for describing any motion we need a reference point. Suppose that your school in a village is 2 kilometers north of railway station. Now 2 kilometers from 2 kilometers north from railway station. So this railway station is the reference point. So position of the school with respect to the railway station is 2 kilometers north from the railway station. So railway station is the reference point. So to describe the position of the object we need to specify the reference point. Sometimes it is called as origin. So you have to choose a reference point. Next is motion along a straight line. So Suppose that an object starts its motion from O. O here is a reference point. This is the origin. Let the object move from O to A. So the total distance covered by it is 60 kilometer. So here the distance is 60 kilometer. Now if this object come back from A to C, then total distance covered by it is OA OA plus AC. OA plus AC, that is 60 kilometer plus 35 kilometers. So total distance is 90 kilometer. So distance is the actual length of the path covered by the object. Here we specify only the numerical value 95. 95 is the numerical value, kilometer is the unit. So in distance, to describe the distance, we need to specify the numerical value, not the direction of motion. Direction of motion is not required. But in case of displacement, we need numerical value as well as direction. That's why distance is called as scalar quantity and displacement is called as vector quantity. Distance is a scalar because it has only magnitude. Displacement is a vector because it has both magnitude as well as direction. This displacement is the shortest distance covered by the object from initial position to the final position of the object. It is known as displacement. Now in this case, what is the displacement? If object move from O to A then come back to C, then what is the displacement? Here displacement is the shortest distance between initial and final position. This is displacement. Shortest distance between initial and final position is called displacement. So displacement here is 25 kilometer. And if an object move from O to A then come back to B, then total distance is 60 plus 25. 60 plus 25 equal to 85 kilometer. But displacement is from O to B, displacement is 35 kilometer. Now distance can be equal to displacement and distance can be greater than displacement, but distance cannot be less than displacement. This is also one of the important difference between distance and displacement. Displacement can be zero. Suppose that an object start from O and come back to O, then displacement will be zero, but distance cannot be zero. Distance will be 60, then plus 60, 120 kilometer, right? Displacement can be zero, but distance cannot be zero if the object is in motion. When an object move in a circular path, this is the initial position and object come back to its initial position after covering some distance. So displacement here is zero. Displacement is zero, but distance is not zero. Distance is equal to distance is equal to 2 pi r, equal to circumference of this circle. Now displacement can be equal to distance and it can be less than distance, but it cannot be greater than distance. So keep it in mind. These are some differences between distance and displacement. Now I will give you some classwork where I will post some questions. You have to answer them in the reply. Okay, thank you.